Hi, everyone, and welcome once again to one of our virtual events. I'm Cindy Oser from the Hobby Memorial Library on Central Texas College, and we have a special guest today. We have Mr. Josh Johns, meteorologist from First Alert 25 ABC. We are thrilled that he's going to finally answer the questions of why is Texas weather so crazy? So I'm going to go ahead and let him get started. Thank you so much, sir, for being here with us today.
Hey, thank y'all for having me. I'm going to at least attempt to answer that question. I mean, there are a lot of factors as to why our weather is so crazy here in Texas. I'm going to share this real quick over to my Facebook page so that some viewers can see it as well, if I can figure out how to do that real quick. There we go. Sorry. Wanted to take a little moment to do that. Yeah, Texas weather is just downright crazy. You've heard it time and time again. We're going to try to dive into why that is, some causes of it, some of the crazy events that have happened here in Central Texas, and how to be prepared for them, and then also what the future might hold. So before we do that, I want to give you a little bit of a look as to who I am and my experience with Texas weather. So I think we have a PowerPoint available. Once that's up, I'm taking a swig of water real quick. Once that's up, we'll talk about it. So the title of today's presentation, what's the deal with Texas weather? I'm the morning meteorologist at 25 News, KXXV, and KRHD. We cover Waco, Temple, Killeen, and also Bryan College Station. So a large area we encompass. Let's go to the next slide. I'll tell you a little bit about me. I was born in the Fort Worth area near Cleburne, Texas. So I grew up in Tornado Alley. Really got bit by the weather bug early because we just kept having these storms after storms after storms and big tornadoes that moved through North Texas as well. That kind of led me to be fascinated with weather. And then at an early age, I decided I wanted to be a meteorologist on TV, helping keep people safe, like those that kept me safe when I was younger. So I took steps to do that, became a Skywarn storm spotter. You may have heard of those. They're the folks that go out in the storm, relay what they're seeing to the National Weather Service, and a ham radio operator so I could communicate with the National Weather Service. And then finally attended Texas A&M after graduating college. My Aggie ring's missing today, but I will give a big gig 'em and a whoop for attending Texas A&M to get my Bachelor's of Science in Meteorology. So I have a full-fledged meteorology degree, internships in Waco and Dallas, Fort Worth, and then all those spots you see on that map are places I have worked. So I've experienced a large realm of Texas weather. And let me tell you, it's not just Central Texas is crazy. It's the entire state that experiences some of these crazy weather. Let me tell you a little bit about the Texas A&M Meteorology Program in case you're wondering about meteorology yourself and how to get involved with it. That's going to be on the next slide. Texas A&M's Meteorology Program is one of the top in the nation. OU, Penn State, Florida State, they're also up there. It turns out meteorologists in all sorts of applications, not just folks on TV, but also folks in research and practical meteorology, and also in government as well, government and military meteorology as well. Up to the doctor's program is what you can get at Texas A&M, and especially in the broadcast program, at least, students put out daily forecasts on air, on radio, and on TV. So it really preps them. That's what I went through. They have a radar on top of their building, and recently the focus has been in research and pollution meteorology. Now I'll give you a little bit about our news coverage here at 25 News, and then we'll dig into the crazy facts that are Texas weather. So that next slide is going to show you the area that we covered. And you notice it is a wide area, not just Waco, Temple, Killeen, but out towards San Saba, all the way over to Madisonville, as far north as Hillsborough, and as far south as Caldwell and Georgetown Bryan College Station. Now, we have a four-person team of weather experts. Our chief is Chief Meteorologist Matt Hines. He has 20-plus years experience, more than 20 years experience in Texas weather. So I've been able to learn a lot from him in the 2 years I've been here, and continue to learn a lot more from him as well, as he's also been across the state. We cover a 21-county area. Like I said, Central Texas, Brazos Valley. There's a huge variation of weather just in our Central Texas area. So now let's talk Texas weather. I'm sure you've heard it time and time again that the weather is just crazy here in Texas. So I got a little bit of a picture to show you that's kind of funny on that next slide to tell you about at least how weather is. I think Drew Carey says it best. If you've seen Whose Line Is It Anyway, they have a little thing where they talk about how the score works there. Well, in Texas, the weather's made up and the seasons don't matter. That's how it seems like some days, just with the big flips in weather that we see here in Texas. So this next slide, we'll talk about some extremes in Texas weather and kind of show you how crazy it is. Our hottest temperature ever recorded on record in Texas, 120 degrees Fahrenheit. That happened in Seymour and in Monahans. Seymour is up towards the north, towards Wichita Falls. Monahans is out in the desert of West Texas. That happened in 1994 in Monahans and 1936 in Seymour. But it has gotten as cold as negative 23. So you're talking about a variation that's 140 degrees from the extremes that Texas has seen. That happened in Tulia in the 1800s and also in Seminole in 1933. Both of those are in the Panhandle. We've seen close to 109 inches of rain a year in one spot. That happened in Clarksville in northeast Texas. And we've seen as little as 1.5 inches of rain in a total year. That happened in the Big Bend, a town in Presidio. In addition, we get some huge extremes just in a 24-hour period. Alvin saw close to 43 inches of rain with Tropical Storm Claudette that hit in the 70s. And then the wettest year statewide was 41 inches of rain. The driest year, close to 15 inches. So you can already get the picture that Texas has a big spread. You don't need me to tell you. It's just the facts help to back it up. And one thing I found interesting, I didn't even know this until the other day, which is bad on my part, but in my hometown, it was the record 24-hour record snowfall, and that was in Cleburne in 1979. And of course, with Texas, we get tornadoes. So move to the next slide, and we'll talk about the tornadoes that come through here. Texas leads the nation in how many tornadoes they have seen on average per year. 6 of those have been F5s since 1950, and 3 of those F5s, the largest type of tornadoes, were in Central Texas. We average in this state about 140 tornadoes per year. Let's kind of break that down to Central Texas on the next slide, or at least north in Central Texas. And you'll notice that while we are active with tornadoes here, there's more activity to our north. There's a reason for that. We'll kind of dig into it a little bit more. But still notice that since 1880, we've had 60 tornadoes or so in McLennan and 60 tornadoes or so in Bell County. McLennan and Bell County are showing the most tornadoes, and part of that is because you have more population, so they're able to see it. But bottom line, we get all sorts of weather, and tornadoes are still a factor here in Central Texas, despite the fact we're on the edge of Tornado Alley. But let's dig into one of those big tornadoes and talk about some of the historic tornadoes, or at least the F5s that have worked here through Central Texas. That next slide, we'll talk about the Waco tornado. It was an F5 that hit in May 11th of 1953. It's the deadliest tornado that occurred since 1900 at that point. 114 people unfortunately lost their lives and 597 were injured. 600 homes and businesses destroyed and over 1,000 homes and businesses damaged. In 1953, the damage this F5 tornado caused was close to $41 million. If you fast forward that to today, you're talking about $421 million worth of damage that came out of that storm in Waco. And it led to a lot of advances that we've seen that now help to keep us safe. After that tornado moved through, a bunch of folks in the industry and in academia met together at Texas A&M in 1953 in June to have the Texas Tornado Warning Conference, of which the idea of a nationwide network of radars was kind of proposed, and that kind of got the ground rolling, plus protocol on how to warn areas of tornadoes and also how cities can help keep folks alert of those tornadoes that come through. And interestingly enough, the same day we had an F4 tornado occur in my last market I worked in, which was San Angelo, mere hours before the Waco tornado. So everything kind of tied together. Another tornado, and this will be on the next slide, this was one of the bigger F5s as well, happened again in 1997. So not only has Central Texas seen one of the biggest tornadoes, they've also seen another F5 tornado. And yeah, go ahead and play some of that video and see if it'll play while I'm talking, if that works. Maybe it's part of the way. Or pause it. That works too. That was when it started early on. It was just a little tiny tornado like that. But then it expanded, and the Jarrell F5 tornado became close to 3/4 mile wide. And if you think about that, that is a large area as it's all moving through, causing that damage. 27 folks died in that, and 12 were injured. It caused less damage because it hit a more rural area than the Waco tornado. But this, I believe, was stronger than the Waco tornado. Now, we have no way to prove that just because the observations that we had in Jarrell were not as same as Waco tornado, but we had reports, or there were reports of the ground being sucked down 3 feet through the ground, just ripping pure earth. So you were talking about a lot of suction. The crazy thing about the Jarrell tornado, one, it was part of a larger outbreak that caused quite a few tornadoes, a F3 that happened in Moody, Belton, another one in Cedar Park, and an F4 in Lakeway. But the unique thing about the Jarrell tornado is it moved the exact opposite direction of what you would think a tornado would move. And that kind of tells you they can be kind of unpredictable. But this one actually followed down a boundary, moving to the southwest. So it's something that's been researched since. And it's really interesting because they found that it had a high energy environment, but not a lot of shear. And shear is required to form a tornado. So that's real interesting that they found that. And it's something that's going to be researched, and one that personally fascinated me and I continue to try to learn about. Next slide, we'll talk about hurricanes. Texas. And you had many other big ones after that. Carla hit in 61, Allen in 1980, Allison, which was not a hurricane, but a tropical storm that dropped an enormous amount of rain on the Houston area and kind of stalled out, proving that you don't need a hurricane to cause a big issue. You can have them with tropical storms. And then, of course, Hurricane Harvey, which happened in 2017. That was one of the second costliest hurricanes in the country, and it is the costliest now in Texas history, replacing Celia that hit Corpus Christi back in the 70s. $125 billion in damage. Keep in mind, that's quite a bit more than the Waco tornado, and part of the reason that hurricane encompasses a larger portion of the area. Let's go to the next slide, and we'll talk about another event, because this is one that, you know, Texas is not really known about, but really got us this year, and that was the Texas deep freeze. We spent 205 hours below freezing or at freezing in Central Texas from the 10th of February all the way to the 19th of February, and that shattered the old record, which was set back in '83, which was one of the colder winters on record. That record was 150. So you're talking about a deep freeze that we really hadn't seen before here in Central Texas. So let's talk about how that kind of transpired with the next slide here, at least what we were seeing in the models. The thing that happens is in the winter, you're looking up to the north because a lot of what brings the colder air is colder air that is built up in Canada. And then eventually something has to dislodge it and dive it southward. The weird part was we were in a La Nina year. That typically is warmer. We're also in a La Nina year now, but don't get too carried away and think that that's going to happen again. A lot of stuff has to come together. But what happened was in a La Nina year, even though you're warm like that, you can still get some sharp cold fronts, some sharp intrusions of deep cold air that can come in. And one of those causes Texas deep freeze. Now, we saw the potential for some of this to break off in the models as early as February 6th. So you're talking close to 5 to 7 days out. And this is when we started talking about it on air. It's kind of weird to talk about cold air on air in Texas because, you know, typically we see things happen in the models and it just doesn't transpire. Think about how many times it looked like it was going to snow and then we don't get it here in Texas. But we saw that there would be a significant chunk of cold air to come in, and it would come in two waves, and started talking about it there February 6th with that cold front that was going to dive to the south. That second wave really resembling the classic look that has brought some of the coldest air that moves through. So let's talk about the first front that came through, and I'll tell you something interesting about it on this next slide, and it'll tell you more about the first front that came through. One thing models struggle with in the winter is how cold that air is as it comes down to Texas. So that presented a challenge for us. It ended up being colder than expected, at least the air that came through from that first cold front. And that meant that it allowed for the switch over from rain to snow a little bit quicker. So even though we thought, you know, maybe we'd end up with things a little bit close to freezing, but not really below, it quickly dropped below freezing. And that combined with moisture that streamed over it, because all you have to do is once you get that cold air mass in place, You just get a few upper level storms to come through, and that's enough to cause some of that. And it was just the perfect storm that happened multiple times. So the first wave came from that first front. And if you are familiar with Bell County, Holland got slammed by this freezing rain that formed. It was largely an ice event. Let's go to the next slide and talk about the second front that came through, because really it was 3 waves that came through with this entire winter storm, which also is unprecedented. You don't see that often, if at all, in Texas, where you get a cold air intrusion and then 3 distinct winter storms building in with it. So the second front, we knew that the first front had already caused issues. We're trying not to freak out the public, but the second front had the potential to be downright record cold. So we had to talk about the potential for this to be life-threatening, because this is cold air that, you know, folks that were born since 1980, including, you know, myself, had never felt. So we had to learn how to balance that and talk about the coverage while not freaking out the viewer. Models continued to get colder. I remember looking at Matt and saying, there's no way this is going to happen. And he looked at me and he said something along the lines of, I know, don't trust the models all the time, but in this case, this is going to happen. He said, all the stuff is lining up correctly. It's scary. So the models continue to get colder with numbers we hadn't seen in 30 or more years. And so that was challenging for us, because we had to walk that level between panic and accuracy, but we knew the potential for life-threatening cold and a crippling winter was coming. And so we had to get creative with our graphics. You can see some of those down there, including one that I made on the left. And you can ask Matt, he'll tell you that I'm very conservative when it comes to forecasting. That was one of the least conservative things I've ever done with forecasting, and saying that, hey, there's potential the entire state shuts down from this. And the entire state ended up under a winter storm warning with the second front. So the next slide, we'll talk about the second front a little bit. What we found was, as opposed to what the models were showing, and this was one good thing about it, to where instead of seeing a huge ice storm and then switching over to snow, we quickly changed over to snow, because that air came in so cold, the atmosphere cooled not only from the surface, but all the way up in the atmosphere. So everything falling was pure snow. It was a lot like what you kind of see in Colorado. So as that happened, we had a quick change over to snow with heavy snow falling. You can see that on the radar on the top right. And then temperatures plunged into the teens. The reason we saw these temperatures go so cold, and the thing the model struggled with, was the amount of snow that was on the ground, the amount of coverage from the snow. When you get that much snow on the ground, it acts like a little ice box. And so it's hard to really warm up during the day. And at night, you're getting some effect of the cold around it, making things colder. It's what we call the snowpack effect. Because of that, that combination with that and the deep Canadian air that came in led to the record-setting cold, with temperatures diving below zero. This next slide I wanted to throw in just so we had a little bit of a breather in there. You got to enjoy the crazy when it comes. My dog had never seen snow that heavy, and we ran her around at my friend's house and had a bunch of fun. I tell you, it was cold, though, when we were out there. Next slide talks about the final burst of the winter storm. And this was, once that big cold slot had come through, there was yet another storm behind it that came through. And this one, luckily, targeted areas a little bit further south of Waco, Temple, Killeen. But unfortunately, I also moved over that same portion of Bell County to where they got a double whammy that caused all those power outages in eastern Bell County, and then also in parts of the northern Brazos Valley. So we had to talk, hey, I know we've already been hit by these two, but we've got another one on the way. So don't leave your house just yet. Let's talk about things learned from the winter storm, because this is what I always like to do, is when an extreme event like this comes in, try to figure out, hey, what went wrong, what went right, how did our forecast do? Let's go to the next slide and talk about that. One thing we learned, and anyone will tell you this, how many people had their powers out? A ton of people had their power out. We learned that Texas can't really handle a winter storm that well. And there's a reason. I mean, the grid is designed for summer weather. We get big summer type events that get so hot. It's not really designed for the cold air. So we learned that Texas still needs to prepare for that, because of one reason. Texas can still get hit by winter weather. History can repeat itself. This happened in 1983. At least this type of event happened in 83. It also happened back in the 1920s. So 1920, 1983, 2021, it could still happen again. So we need to prepare for it. We also learned that Facebook Live is highly effective. We have folks that couldn't get our signal on air, but since we were on Facebook, they could still get the message. So it kind of ushered in a new type of, I mean, we'd already done Facebook Live, but a new type of focus on, hey, digital matters a lot more than maybe we really thought. There were a lot of forecast challenges, though. I mean, models weren't not going cold enough. Some models were kind of warming the layer above us a little too much, which created models just throwing out enormous ice totals. And that also led to the fact that anyone has access to these models. They can just throw it on the internet and it goes wildfire. So we had to learn how to be effective in our messaging. So, like I said, we always try to learn and improve. And I think we'll be improving on the Texas winter storm. So now that we've talked about how crazy the weather here is in Central Texas, let's talk about why it is. This next slide has another joke for you just to keep things livened up. I'm sure you've walked outdoors and it's been sunny, and the next moment you had a cold front come through, and all of a sudden you're shivering. And West Texas, I experienced a temperature drop where in the afternoon we were sitting at 87, and by the time we got an hour later, the temperature had dropped 37 degrees from a strong cold front. So you're talking about some insane temperature differences in Texas. Let's talk about why that is with the next slide here. A lot of it, believe it or not, very elementary, comes down to location. Texas is unique in the fact that it's so close to a warm body of water, yet so close to also dry desert air that you constantly have air masses fighting. Texas is large, covers a large area. A lot of what we have could be fitting in 5 states. So, you know, we're experiencing 5 states' weather in 1 state. That means it has multiple climates. And when I say climate, we've got to break down the difference between climate and weather. We're talking about weather here, but climate is weather over time. So basically what Texas experiences typically is your climate. Weather is instantaneous. So what is it doing outside right now? Well, it's sunny. And so air masses within these climates constantly battle, which leads to highly variable weather. Even if on average Texas has a climate, it leads to highly variable weather since you have multiple climates in the state. And you can see that climate type map if you look really closely. A lot of the state is in the same climate type, but you have the drier climates off to the west. You also have the super humid climates off to the east, and those clash. So this next slide will show you how that works. And a lot of it has to do with what we call source region. If you're in a climatology class, they'll tell you about this. This is how air moves. And so you're dealing with air that is from the Gulf coming in from the southeast. You'll notice this when you walk outside. It feels humid. That is that Gulf air. What's happening out to the west is you get dry desert air. So not only are you having Gulf air and dry desert air in the same place, they're constantly clashing. And it's that clash that creates thunderstorms and the frequent variable weather that we see. You're also not only dealing with the fact that you have difference in humidity across the state, you're also dealing with the different cold and warm air masses coming across the state. So you have that warm air coming from the Gulf, you have warm air coming from the west, from the desert, you also have that cool air coming from the north. So every time those clash, Texas sits in the battle zone, and so that allows for those type of systems to come in that create bad weather. The next slide will talk about terrain influences, because you can have all this stuff happening at the surface. In order for the weather to get going, you also need stuff coming in above the surface, say in the mid and upper levels of the atmosphere. That gets affected by the terrain across the nation. We're close to the Rocky Mountains. We're close to the Sierra Madre. And then also locally, which has a more of an effect on the lower levels of the atmosphere, we have the Caprock Escarpment and the Balcones Escarpment. Balcones, of course, runs up I-35. The Caprock is out to the west, and that can influence a lot of the lower level patterns. Let's talk about one of those lower level patterns on the next slide, because this is one that creates explosive thunderstorms. I'm sure you've heard of a cold front, you've heard of a warm front, and there's another front, the occluded front and a stationary front. But a front that I think is forgotten a lot, at least in grade school education, is the dry line. And what that is it separates that boundary from that dry air you saw the west on the map to the humid air that's sitting off to the east. And that boundary between the two oscillates as we go through the evening a lot out in West Texas. Now, this is important because wherever this thing sets up, and since it moves, and it doesn't really move actually, I take that back, it mixes, so it moves different as the front. The models have a hard time seeing it. Well, why does that matter? Well, because the dry line can serve as the catalyst for thunderstorms as we get into the spring. You'll notice this if you watch us on air, that we'll be talking about a dry line over West Texas in the spring, and that can pop off showers and thunderstorms. It happened last night. In fact, that map that you're seeing is a model depiction of the dew points that were in place yesterday afternoon. So you had the humid air off to the east, you had the dry air off to the west, and where they meet there's the dry line. That's what actually fired off the storms that moved through this morning here through central Texas. So it's important we know where that's at. I want to move to the next slide here, and this is where you'll pull up that video too. And remember, I was talking about storms in the higher levels of the atmosphere. If you have something on the surface, you still need it to interact with something up top. So not only do we get those surface influences, we also get what's called upper level influences. I want you to look at this video, and you're going to see that the atmosphere moves kind of in a fluid. And so it's going to move kind of like a slinky, like a wave. Each time one of those waves passes us, that can serve as building a storm system down at the surface. So we have one that you saw there early on. We'll hit play once more. That first one is what caused the storms last night. This next one on the way is what's going to cause the cooler air heading on into next week. So that'll be quite interesting. But upper level disturbances interact with those surface features. And what causes the bad weather is when you have a combination of all those levels in the atmosphere. These cause more large-scale effects. So that same system also caused all the stuff that happened in California. You saw the heavy rain there. It affects a large area. These are hard enough to forecast. You add in those surface levels, it can cause issues. But since we are close to the Rockies and the Sierra Madre, those systems coming across like to wiggle a lot. And so that causes issues with our forecast, and it can make it look like the weather's changing on a dime, even just from that influence, not to mention that surface influence we were talking about. So I want to move to another one, and this is one on the next slide that we deal with a lot in the spring. I told you about the dry line. Well, oftentimes that's near us, so you'd think storms could fire, but there's something that can sometimes stop it, and this is something that's also hard to forecast. It's called the cap. The cap is a layer of warm air aloft. What I have drawn there on the right is a reading of the temperatures and the dew points as you go up in the atmosphere. So a cap is a layer where the temperature is warming. And if you look closely, there's like a jut up this direction on that top layer, and that is a cap. This also reads the amount of energy in the atmosphere, this graph you're looking at. And that one at the bottom is the Jarrell energy. And you can notice how the third line is really far off. That was a sign there was a ton of energy in the atmosphere during Jarrell. That was actually taken by A&M students in Calvert. But back to the cap. The cap is a layer of warm air aloft in the atmosphere, in the lower levels of the atmosphere, that serves to kind of cap the atmosphere. It blocks thunderstorms from forming because air can only rise if the air around it is colder. Warm air rises. So if it encounters air that's warmer, then it's going to sink, and that keeps the storms from forming. Now, we almost always deal with this cap in some form. It's either going to be weak or it's going to be strong, and that's because the angle those disturbances you saw in that last slide come from the southwest. That pulls warm air up from the Mexican plateau and puts it over us. But you can thank the Mexican plateau with mid-level south winds forming for that. Thing is, models struggle with this. They like to say, hey, it doesn't exist. And so a lot of times as we're forecasting, we're looking at it, and we have to weigh, okay, is this really going to happen? Stuff like that, and look at the cap closer. But because of that, that leads to high uncertainty and severe weather episodes. A lot of times you're going to see us say, hey, we have the chance for severe weather today. These could fire off and come through. And you're going to think that we're wrong when they don't. Well, a lot of times it's just a hair difference that kept us from seeing those storms. That hair difference was the cap. So that's something you're going to see us talk about in the spring, and that can also lead to this huge variation of weather because it looks like we're going to have severe storms. We come out, we say it, and then it doesn't. And then you start thinking, hey, why are you wrong all the time? That's one of the reasons. Let's talk about some central Texas influences on the next slide, because not only are we dealing with these influences that happen all over the Lone Star State, but we also have our local influences. I talked about the Balcones Escarpment earlier. Well, the Balcones Escarpment can add a little bit more spin to the lower levels of the atmosphere as those systems come across that maybe the models can't see, and all of a sudden you're dealing with a storm that somehow looks a lot stronger than it was going to. It can also affect moisture flow from the Gulf. It can kind of stop a lot of that warm, humid air from getting out to West Texas And again, models will struggle with this because they sometimes struggle with how to resolve terrain. And more importantly, and research that they found recently in combination with universities and also the National Weather Service in Austin, is they found that that escarpment leads to a localized area of heavier rain because that air is being forced up by the mountains, or I mean, they aren't mountains, they're hills, but forced up. And so it's causing a lot more moisture to be available for those storms to put out. And then we also have the urban heat island effect. If you've been anywhere in central Texas lately, you know that we have a lot more people moving in. We have major population growth in central Texas. They already dealt with this in Dallas Fort Worth. We're dealing with this here now. That leads to higher daytime temperatures in the area where a lot of civilization is because of concrete that soaks in that warm air or that heat from the sun than what models would show. So we have to look at that. And it also leads to warmer nighttime temperatures because as that concrete absorbs all the heat in the daytime from the sun, a lot of that escapes up into the atmosphere, warms at night. So areas out in the rural areas can cool off quicker than, say, places in the city. Now, there are some signs this affects storms as they come over the area. Hadn't been quite researched yet, but it is something we're kind of looking at closely, and a lot of folks in the research side of meteorology are looking at closely because, of course, that can lead to your crazy weather. You have a storm coming, and then all of a sudden it's just weaker because of that. It's something that we're kind of looking into. Look at our terrain on the next slide. I want to show you this just because you can see there's a lot of features in there that affect locally how your weather occurs. So all this to say, yeah, it's crazy. It's also hard to forecast. This is why it's crazy because we have so many influences on our weather here in Central Texas. So let's dig into how we can better predict this, where we can do better at this on the next slide to help make it to where the weather maybe doesn't seem as crazy. We can study the weather patterns. That's the only way you can really get better at this is you can look and say, okay, how is this going to interact with this? Because I've seen this happen in the past. Again, history repeats itself. I've noticed this already is that a lot of times these storms can be real bad in West Texas, then come in and they're a little weaker. Why is that? I'm still trying to dig into it. In San Angelo, when we had storms come over the Edwards Plateau, San Angelo is set in a little bowl. So when they came over, I noticed that the outflow happened quicker. As a result, they were weaker, wouldn't produce a tornado unless they came in at the right angle. And then as they moved east, they strengthened. So that's some of the local patterns you can see. So there may be things that you see that I don't. We got to learn model biases. For example, a lot of the models are too warm at night here because a lot of the rural areas cool off quicker. So it's learning those biases. And weather moves in a fluid, so there will be patterns. You're going to see something I don't because weather will kind of repeat itself in a way, not every time because there's so many influences, but you'll start to realize as you watch it more and more, hey, this kind of happens a little bit more. There may be something there. So again, you may see something that I don't. Let me see, which direction am I going here? I'm going south. So the next one's going to talk about how we challenges we face as Central Texas meteorologists. So again, these are some of the issues I just brushed over, but we'll brush over them a little bit again. There's another joke for you. So Susie, you got half the problems wrong. Well, that's okay, Dad. I want to be a meteorologist when I grow up. I can laugh at these. You know, some people get offended. I laugh at them, but sometimes folks really do think we don't know what we're doing. We actually do. There's just a lot of variability. One thing that's causing issues lately is the fact that there's more and more of this modeled data, say that we show on air, that's available to the general public. And so frequently you are seeing these screenshots of models sent out over Twitter, some of them that show just fantasy type land solutions like 12 inches of snow on Christmas a good 3 weeks out because it's available. We have to deal with that. The thing about high resolution data, though, is these models are trying to get higher and higher resolution. I believe they have trouble resolving local features. They can resolve some features, but then they'll overdo other things. When they overdo that, that can lead to maybe making these storms stronger than what they are. We kind of saw that last night where it was overdoing winds that were coming out of the south, leading into the storms and saying, hey, this is actually going to come this direction. And as a result, was showing little spots where tornadoes could happen over central Texas. we kind of knew that that was going to happen a little bit further east, and that's why Houston got it and not us. That's one thing, one example of how these high resolution models can overdo it. But when people just tweet this out freely, it can create panic. So my challenge to you on that is follow people you trust that know the weather and share those people. Don't share Bob's weather page or whatever. Another challenge we have bad radar coverage here in Central Texas. This is one thing we had to deal with last night. The National Weather Service has a network of radars. It's a great network of radars. It covers a large area. There are still some holes and still some issues. One of those issues is the nearest Weather Service radar to Central Texas is in Granger. That's out of Williamson County. It has decent coverage for Bell County because radar scans at an angle. And because of that, the closer you are to the radar, the lower it's looking. And for tornadoes, you want to look at the lowest levels of the radar. So it covers Bell County well. When it gets to McLennan County here in Waco, or at least where our studio is here in Waco, it's looking a good 1,000 feet higher. The storm acts a little differently the higher up you go. So it's harder to see, say, if there's a tornado on radar, the further away you get from radar. So it can't really see the lowest levels in McLennan County. And Granger goes down a lot. It did last night. So the next nearest Weather Service radar then is Fort Worth and also Austin or Houston. Sorry, New Braunfels or Houston. We had to use those this morning. So as a result, it was harder to see that lowest level. So there may have been gusts of wind we weren't seeing on radar with these storms that came through last night that may have been getting a little bit higher, but we couldn't see it because it was so far away. So it was a little stressful morning, to say the least, because of that. And then obviously we deal with public perception. If the weather's so crazy, not you in particular, but folks in the public think, hey, they get it wrong all the time. Well, a 2-degree forecast is not that bad, but it's still wrong, right? So there's a perception of accuracy that challenges us every day. So let's talk about how we can be better prepared for the weather that comes through. And that's going to be on the next slide. And that's paying attention to the weather. Like I said, you're going to see patterns. And also, if you're alert, you're going to know when things are coming through. So have action plans in place. Should bad weather threaten, that's going to help you keep your family safe. And then trust local meteorologists. These national meteorologists you see on the Weather Channel, I can't say a bad thing about them. They are great. They are smart. They know what they're doing, and they do an excellent job. But local meteorologists focus on the local patterns. National meteorologists and your weather app focus a little bit more on the broad scale patterns. How does it affect the nation? So because of that, we're going to know better when a storm, say, is coming in. It's a bigger threat than, say, the national do, because we've seen things happen in the past. So it's important to have a local meteorologist you trust because, again, they know local weather patterns. We'll also exclude bad data. We'll know when the stuff coming in, hey, we've seen this happen in the past, and this doesn't resolve this as well. So that's overdoing that, like what we saw last night, unlike the weather app. And again, don't trust sites like Bob's weather page or something like that. There are a lot of sites out there that are trying to share weather, and the folks that are doing it, that I'm not talking bad about them. They're weather enthusiasts like I was at a point, but there are certain things that aren't known, and you don't want to trust your life with that. And then have more than one way to get warnings. One of our ways, Storm Shield app. I'll put a plug for our station app on Apple and Android, and then follow local meteorologists on Facebook and Twitter. I'll give you my handle here in a little while. Let's talk about what the future may hold. We're getting close to the end. Don't worry if you're already getting tired. That's going to be on the next slide here, what the future may hold and how our weather could change, or at least how we forecast could change as well. Meteorologists are always researching. Sign of a good scientist is they continue to try to learn from what's going on. So new equations are being put into models every day. Already, we have a new model in our system that was developed by IBM that is trying to better predict the weather. Now, it's having issues right now, but in the long run, may do more accurately than, say, the other model that was in our system. Better science is forming because we're learning a better understanding of our environment, and that's being put into the models as well. So we should be finding more efficient ways to resolve those small scale features that cause a huge variability. We already have a good outlook on large scale features, like those chunks of Arctic air we talk into. The problem is those small scale features, like how far is this front going to make it? That is still trying to be resolved, and that's what the biggest research is in right now. And also those small scale features are why some areas see tornadoes and some don't. So a lot of that is still going in. So as we learn more and more about this, ultimately, it should lead to better predictions, or at least more accurate predictions. There will still be times it's wrong, though. So it's important to stay aware. One thing that could help is a denser observation network. This is going to require government intervention as well. Oklahoma has a network of observation stations that cover the entire state. Texas still has a lot of holes. That feeds into the models as well. So if we get a denser observation network, which may happen in the future, depending on how things happen, that could help predict things and make it easier to find local features. Also, a denser radar network. I told you it's a great radar network, but there is still a hole. One of them is out in Crockett in East Texas. Another one's up in Durant in Oklahoma. That one is about to be filled, and so Northeast Texas will have a good little radar coverage. There's still a hole east of 45, north of Bryan College Station, that's still a problem. So you need a denser radar network. Would help with predictions as well. It's especially the west, out in the mountains where there's a lot of holes. And a denser radar network will require government support, of course. Will allow for better storm detection because then you can see the lower levels of the atmosphere. And already they're experimenting with this in the Dallas-Fort Worth area. Some private sector, say university, and also sponsors have gone in and say, what if we put a bunch of smaller radars everywhere? That's what they're doing in Dallas-Fort Worth to try to do that. So better radar technology will help too. Right now, our technology scans out and it also scans up. It's called dual pole technology. That helps us see the shape of the raindrops and kind of lets us tell, hey, this isn't rain, this is actually debris. That's one thing that's come out in the last 5 years. We can see debris on radar when a tornado comes through, and so that's helping us. It also helps us with winter weather because then you can see that snow, rain, ice all have different shapes. That has helped a lot. One thing that's about to come out is phased array radar that they're developing. That's going to allow it to scan in multiple directions at once instead of all in a radial, which means you can have part of the radar focusing on a storm and the other running another way. Also, more efficient radar scans. They're constantly figuring out, hey, how can we change this pattern so that we get the most important radar data first? That has also been something that's come out in the last 3 years. And now instead of every 5 minutes getting a radar picture of what a storm's doing, and the lowest levels, we can get it up to every 1 minute now. That's really helping with tornado detection. And then one thing that we're still trying to figure out, what's the effects on climate change? I'm not going to dig all into climate change because that's a whole nother conversation. But one thing that's happening is when the atmosphere is warming, so is that water that's in the Gulf of Mexico. Because of that, we will have more moisture in our atmosphere over the future, which, what's the full effect of that? Well, one is we should see more prolific rain amounts, but how is it going to affect other parts of what our weather does? That's still being researched as well. So hopefully that kind of gives you an idea of how crazy our weather is. The next slide will give you my contact information of how crazy the weather is and why it is the way it is, at least a little Cliff Notes version. There is a million reasons we could get into, but for the sake of time, we won't really get into it. But hopefully it gives you just a little bit of a benchmark on how to start and kind of understand a little bit more about the atmosphere and the crazy weather we deal with here in Central Texas. So with that, I know I said I'd take some questions. You can go follow me on my pages there if you have questions as well, and also for updates on the weather. But questions, I'll try to answer them to the best of my ability, but let me take a swig of water first.
Lee, do we have any questions from our viewers right now?
There's no questions on Facebook at the moment.
Okay, I have many questions.
Okay.
I've lived in different parts of Texas, but I'm from Louisiana, a totally different state. Some of the things that I've noticed, especially living up in the Dallas area, the lightning seems do these land formations, does all that affect lightning at all? The lightning is seems like it's just right there 5 feet above my head in Texas. And it was not that way in Louisiana.
Well, what you're talking, are you talking visually or sound?
Both.
Visually. So I think part of that, I don't know fully, but it wouldn't surprise me if because of the interactions we have, if maybe we're seeing a little bit more of that spider lightning, or maybe it's easier to see also because we don't have as much humidity as, say, Louisiana. Maybe that makes it easier to see. And then as far as frequency of lightning, we have more structures and more terrain here in Texas. Lightning's always going to find that shortest path. So if you have more structures and you have higher hills, maybe more transmission towers, that lightning will find a way to hit it a little bit more. And so I think the frequency would go up a bit more. But it also, and it's just off the top of my head, uh, lightning needs ice in a storm to happen. So this is why hurricanes don't produce a lot of it, because a lot of that is tropical moisture. And because of that, you don't have any dry air in the mid levels of a storm, like say you do when it's over land. So when a storm produces more hail, you're going to see more lightning because of that. Those are the ice particles that are in the storm. And so Texas probably has more access to drier air. That being said, I know lightning, the center of most lightning activity has been shifting back and forth between the east and the west lately. From my time at A&M, I remember them talking about that because I actually researched under the lightning prof there. But that's just a few of my guesses. It's not a definite answer.
Oh, well, that's it. It just makes me feel better that I wasn't imagining that lightning was out to get me in Texas as
It's
opposed to
more
Louisiana.
percussive state. I know in San Angelo when I was out there, it felt so much louder, so much percussive. I think part of that was because dry air heats quicker. So your thunder is more intense, quicker instead of rolling. At least
Okay.
that's.
Well, I have another question about microbursts.
Mhm.
One day at lunch, I was driving home, in Bryan, and I turned on my street, and there were fire engines and everything there, and every leaf and every tree had been locked off of the trees.
Mhm.
And it was just on our block, and they said it was a microburst. What is a microburst?
So a microburst is where you have a lot of. So as a storm forms, you get a lot of moisture in it, and you have a downdraft and an updraft within a storm. But a microburst is when you get a localized area where you get a ton of moisture in it, and eventually the storm doesn't support that very well, likely because it's not as organized, and it'll just fall to the ground because of physics. As it falls, it accelerates. So it actually comes straight down and then spreads out in loops like this. So that microburst may have happened right on the tree and just shoot it all the way there. But it can be very localized, very strong. It's more common in the summer months because you don't have as much shear to support a storm, because you can have all this energy, but you need a shear to kind of keep it organized. And in the summer, we have less shear. So you're likely going to see those more around June, July than say March or April. Storms can still produce those gusty winds, but as far as real localized microbursts, as opposed to say a macroburst, which is bigger, that's when you see the microbursts. They can be quite damaging though, and quite they're hard to see because they form so quickly and fall. You just see like a little expanding area in the wind mode of the radar that you notice, hey, that's different.
That was definitely different.
Oh, it's
Um, Talking about the hard to see, and you mentioned about the tornadoes that y'all are learning your research, you're able to see the tornadoes quicker. There's been instances when I lived up in the north of the North Dallas area, and where they've had all these tornado horns, and they missed one. It just came down and went through a neighborhood, and they didn't see it coming.
Mhm.
So, do you guys depend on both people to like your tornado spotters, your storm chasers on top of your radar?
Yeah. Oh, yeah. No, in fact, we will value reports on the ground more than what we see on radar, provided that we know the person on the ground knows what they're looking at. And that's not to say that everyone doesn't know what they're looking at. It's just there are a lot of sneaky things that can look like a tornado and can be called by a tornado that, unless you're trained on that Skywarn storm spotting, which the Weather Service does for free, it's a great thing to go out and do. You won't be able to recognize as a true tornado as much as, say, a shelf cloud or a wall cloud, which can look like it. And then back to your point on missing that, having all of this radar technology, all this warning is great, but there still needs to be that communication between emergency operators and meteorologists, weather service folks to get that out. So maybe that communication broke down. Also, if it happens so quickly, sometimes it can happen so quickly the National Weather Service can't get a warning out in time. And a lot of those EMs rely on a warning to come out to kind of display that. I'm checking my battery here because I'm still good. I see a spinning wheel on you. I wanted to make sure I was still okay. So if it happens so quickly that the Weather Service can't get a warning out, that kind of leaves the criteria way for your EMs and also for us on air, because a lot of times we have to have a warning out to be able to break into, say, The Bachelor or something like that with that information. So, yeah, all the technology is great, but it's only great as long as the warnings are still getting out. And the Weather Service does a great job at doing it. There's just sometimes that they're focused, say, on a certain area and something may come up. And that's what we're watching too, because the Weather Service, for instance, in Fort Worth, great folks, they have to cover Fort Worth and Waco. Which one has more population? Fort Worth. So they're going to obviously be focusing on that if there's a threat there. And that's where we kind of have to fudge the lines a bit.
Well, and when I moved here, I heard something crazy. But after listening to you, I mean, that didn't come out right. Um, I'm wondering if it's the escarpments that are doing it. I was told that it rains east of 35 and it doesn't west of 35. I was told that when rain comes, it hits Copper's Cove, goes around the ridges, and then bypasses clean altogether and then keeps going. Does this
So,
have to do with your barriers there? What is that?
so that's something that everyone thinks happened in their town. This is the answer I have to give, and then I'll give you a theoretical answer. But that's something that everyone thinks in their town because of perception. Hey, it's coming towards me and then it doesn't. Radar is not perfect. It's not going to see it all the time. There could be certain things happening in the upper levels of the atmosphere that's drying it out. That being said, there are terrain influences on storms. They're still researching that. As far as it raining more east of I-35, not particularly saying in that instance, but east of I-35, since you're east of the escarpment, 35 runs along it, you're going to have access to more moisture. So a lot of times you're going to see more rain on average east of I-35. Maybe not within a particular storm as it moves across, because I've also seen it where a storm moves across, dumps a ton of rain in Killeen, dumps nothing in Temple. So that is the old tale that's always told. Oh, it always splits around me, because I thought it growing up. And my theory was because to my west, there was the Comanche Peak power plant, was that they were shooting a ton of steam up in the atmosphere. It was accelerating how the storm processes and making it split. Still, everyone thinks it. Could there be logic to it? There could be. It's just not been researched enough. Because, I mean, we think the same thing about the Waco airport. It comes in, for some reason, always lower than what happens in town. Well, part of that's further away. Our observations make a difference too. Skylark is right in the center of Killeen, but you could be using an observation from the Great Army Airfield, which is on the west side. Sometimes the display's different in our system, but as far as it's splitting all the time, that's a tall order. I'm not saying it doesn't happen. I'm saying everyone thinks it. There could be something to it. We just don't have any proof that there is.
That makes sense. That makes sense. Thank you. Because I'm like, how does it know Highway 35? I never could figure that logic.
There is terrain influence. I don't know what, but there is a terrain influence because I've seen how things behave differently as they cross over terrain out in West Texas and also here. And there's also something to it in Oklahoma as to why Oklahoma City and Norman see more tornadoes than, say, there's also the influence, obviously, of more population there, but they are researching how do these little small ripples in land cause differences. And that's microclimate, which is going to take forever to research, but there are researchers doing stuff like that. So
That's
hopefully we'll find
amazing.
out it in the future. That'd be awesome to know, because then you could say for certainty, hey, we can still play football. This thing's going to go around us.
That would be great. That would
That'd
be great.
be awesome.
Well, Lee, are there any other questions? I've just had a bunch.
There's one. Do you have an indication that Texas will have a similar winter storm like we did this past winter?
So that's a tricky answer to say, because what happened that actually broke up that chunk of air in Canada, because the thing was that air was just sitting there getting colder and colder and colder, and nothing came through to grab it until something finally did. And what happened was the jet stream closer to the polar side, you have the polar jet stream, you have a lower jet stream. That polar jet stream completely broke down. So it was a very rare event where that happens and that comes down. The likelihood of it happening again is extremely low. I will say this, though. We are in the same La Nina type pattern that we were last year, which means on average, we're going to be warmer, but we're still going to see sharp air intrusions. We've already seen some hints that the upper level pattern, at least right now, has the same type of activeness as far as storm potential is to what it did last year. We don't know if that means it will repeat in February, but it means, hey, we got to watch this a little closer. So the likelihood of it happening, very rare to see it. We are in a La Nina year. We will still get cold outbreaks. I'm not saying they're going to be cold as last year because I'd be foolish to say that. But because of the perception of we're in a warmer type year, those cold outbreaks may feel a little sharper. I'm crossing my fingers it doesn't happen again because that was all hell. And Texas doesn't need to go through that again. It's always smart to be prepared, though. So now that it's happened, you know how to prepare and you can just have a little plan in place should that start happening. But as far as it repeating this year, there are no indications we see yet. But that's also something that doesn't show up 3 months out very well. That's something that you won't really see until 5 to 10 days out. So that's why we need to just watch the patterns closely. But I mean, not saying it won't happen, but I'm definitely saying it's not likely.
Awesome. Awesome. Thank you.
Mhm.
Any other questions, Lee?
No, that was it.
Okay. All righty. Well, we have definitely taken your time, and after finding out what time you showed up to work today, you're probably ready. You're probably ready to go. Thank you so much for taking the time to talk with us today. It's been a mystery. What Texas? You always hear about crazy Texas weather, and you gave us an indication of what's going on.
Well, I'm glad. I hope that folks could walk away learning a little bit more about what's happening and maybe a little bit more understanding of why it's so crazy. And part of the reason I'm so fascinated by it because the job never changes because of that. It makes life interesting.
That's awesome. So yeah, definitely, guys. Meteorology is a really awesome career. Every time we have a guest, I'm like, but I want to be that when I grow up. So, and hopefully, Lee will put the, all your contact information in the comments, and we will go ahead and, have that in there so that if anybody wanted to contact you with another question.
Mm-hmm.
So, eh, yeah. And before we go, guys, remember that tomorrow we have another night sky tour with our astronomer, Warren Hart. We're going to be streaming that one live on our library's Facebook. And if Lee will put that in the comments, that you're going to be seeing that night sky tour on our Facebook. Then on Monday, we're back on CTC's Facebook. Monday, November 1st, we have soil testing. It's pretty much how to feed your plants with Professor Keaton Airing. And we also, on November 3rd, from the business department, Professor Drake, how to start your own business. So very wide ranges of topics, and that one's also going to be on CTC's Facebook. So thank you so much for joining us. Thank you, Josh Johns. You were amazing. Thank you,
Thank you.
Lee, for streaming for us. And you guys, everybody have a great day because the weather has turned beautiful. Mr. Johns would know that.
Except for it's going to be breezy.
Yes, yes. So thank you guys, and y'all have an awesome day, okay? And Lee, you take us out.